In the moments following the Big Bang, the universe was astonishingly simple. There was no carbon, no oxygen, no planets, and certainly no life. There were just vast, empty swirls of hydrogen and a little bit of helium waiting in the dark. This chart shows the elemental assembly line inside those very first stars. Gravity acts as a vice, crushing lighter atoms together in nuclear fusion. Hydrogen fuses into helium, releasing enormous energy, which then cooks up carbon, oxygen, neon, and silicon. But look what happens when the star tries to forge iron. Iron has incredibly high nuclear binding energy. Instead of releasing heat when it forms, fusing iron absorbs it. The star suddenly runs a massive energy deficit. Without the outward pressure of fusion to hold up the star's immense weight, the core collapses inward. The resulting rebound is a supernova, a catastrophic explosion that rips the star apart and blasts that newly minted iron out into the interstellar void. That scattered stellar debris eventually clumped together to form our solar system. The astronomer Carl Sagan famously observed that we are made of star stuff. He meant it quite literally. Every single atom of iron in existence right now was forged in the dying fires of those ancient, exploding stars. When the early Earth was still a molten ball of rock, it went through a process called planetary differentiation. Lighter materials floated to the surface to form a crust, while the heaviest elements, like iron and nickel, sank deep to form a massive metallic core. Down there, nearly 3,000 kilometers below our feet, temperatures exceed 5,000 degrees Celsius. The intense heat escaping from the solid inner core causes a surrounding ocean of liquid metal to boil up and rotate in massive convection currents. This visual illustrates the geodynamo effect. Because Earth is spinning, those churning flows of liquid iron organize into a giant electromagnetic shield. This magnetosphere extends tens of thousands of kilometers into space, deflecting lethal solar wind that would otherwise strip away our atmosphere. Earth survives because it is an active mechanism. A massive volume of iron kept in continuous motion generates an invisible boundary that makes complex biological life possible. That same stellar element also powers you. If we zoom in to a single red blood cell and look at the center of a hemoglobin molecule, we find a lone atom of iron. That specific atom is what gives blood its metallic taste. Its unique properties allow oxygen to latch on securely in the lungs, ride safely through the bloodstream, and detach exactly where your cells need fuel. The human body is packed with a vascular network that, if laid end to end, would stretch for over 100,000 kilometers. At the center of this network sits a pump, forcing billions of these iron-carrying molecules through those channels every second. The Earth survives because it circulates molten iron beneath its surface. The human body survives because it circulates iron-bearing fluid beneath the skin. Both rely on a continuous flow of stardust. We usually think of the brain as the body's primary electrical command center. While the brain is highly active, its electrical signals are scattered across many different neural networks, firing at different rapid intervals. Comparing the raw electrical amplitude, the heart produces a signal roughly 60 times greater than the brain's. Looking at magnetic strength, the difference is staggering. The heart's magnetic field is up to 5,000 times stronger than the brain's. This massive surge of energy happens because the heart functions as a highly synchronized oscillator. With every single beat, billions of individual cardiac muscle cells depolarize and recharge at exactly the same time. Because of that perfect synchronization, the heart generates a potent, measurable electromagnetic field. Depending on the sensitivity of the instruments used, this field projects up to 15 feet outside your physical body. Researchers at the HeartMath Institute have found that this field functions like a wireless broadcasting system. When you stand near someone, your nervous system acts like an antenna, picking up the subtle magnetic shifts generated by their heartbeat. Here we see how emotion modulates that broadcast. When someone is anxious or angry, their heart rhythm creates the jagged, disordered waves on the left. Intentionally feeling positive emotions like appreciation produces the smooth, orderly pattern on the right, a state called heart coherence. This leads to a measurable biological event known as brainwave entrainment. If you have a highly coherent, rhythmic heartbeat, the brainwaves of the person sitting next to you will actually begin to sync up to your pulse. In clinical settings, the cardiac energy transferring between two people is strong enough that one person's electrocardiogram signal can physically show up on another person's electroencephalogram brainwave readout. We are constantly physically projecting our emotional states outward, shaping the neurological harmony of anyone standing nearby. That synchronization becomes incredibly powerful during physical contact. When a mother holds her infant close to her chest, her stable, coherent heart rhythm directly entrains the baby's brainwaves, soothing their nervous system. That ability to project calm, to physically wire another human being for comfort, relies entirely on the electrical properties of the blood flowing through her veins. Scale out from that mother and child, and you find the exact same element swirling deep inside the Earth's mantle, generating the planetary shield that protects them both. Scale out further, and you arrive back at the dead stars that sacrificed themselves to forge that iron in the first place. Every time your heart beats, it pushes a microscopic piece of ancient stardust through your body, generating an invisible field that allows you to connect with, protect, and heal the people you love.